Hello everyone, we are beginning the routing security SIG here. Thank you for coming just before the time begins. I think I need some stories about the routing security SIG before starting a speaker's presentations because the people are still outside of the room. I'm Taiji from APNIC, and I'm a new co-chair of the routing security SIG. And this is my first time to chairing the session in APNIC meeting, I think. Before my chairing this session, Madi, I think he should be not yet, continued this routing security SIG. And he said to me, this is a place to talk about the RPKI and the ROA operations, ROV operations. Right before this SIG started, I and guys interested in RPKI did RPKI BOF. So he said the RPKI BOF was the reference place to bring this SIG. So it's very honored to be here for me, and I should think about it deeply, not just the technical, not just operational, but you can enjoy this session and valuable for your work, study, and discussions. Thank you. This is the routing security SIG. Next slide, please. Those are same with the sentences on the web. Thank you. This SIG charter is to provide a platform to discuss the operational issues and best practices to secure global internet routing. The SIG will be the forum for discussion about broader internet routing security topics, including RPKI, IRRD, etc., which are very much related to network operators. The SIG will act as forum to develop and clarify development of services by APNIC such as RPKI, IRD, RRDP, etc., and collect feedback from network operators about what changes they want and how it is possibility negatively impact their operations. The SIG will focus on information sharing, outreach, capacity building, and other activities that will advance APNIC's vision for a global, open, stable, and secure internet. A very good charter. We can do everything. So I thought about the first time this session, it's going back to the beginning. So the first speaker is Team 1 from APNIC, the deployment experience on APNIC ROA, ROB. In AP region, we as NIR need to deploy the new operational things, I mean the additional things for operators and IP address holders. So before that, we need to discuss and build the subsystem and created a strategy to deploy the additional things. So then the next talk about from APNIC guides, RPKI Asia Pacific update in the ASP and IETF updates, they are not just technical things, but technical things. And the last one, Xian Lihu's research presentation, RPKI Monitor, Modeling and Measuring Internet Registry Conflicts in RPKI. This is very interesting to registries and routing guys, I think. And the last part, I give the 3 themes to discuss at the last part. And I already passed the 3 questions for some attendees, and they will give their own thought at the last. So please, Tim, come to the stage, and could you give your presentations?
Okay, good afternoon, everyone. I'm Tim Wang from APNIC. Today, I will share the deployment experience on the APNIC role and the ROV experience. And this is the APNIC RPKI architecture, and for the RPKI component and the other interaction with the APNIC build our own CA server and sign the certificate with the APNIC CA server. And with the APNIC, they do their study engine and the RPKI database and the APNIC registry database. And the APNIC, the CA server, we have our own RPKI database and our APNIC registry database. So we know the member, the ID, the IPv4, IP address, the resource, and the ASN. And we have built my RPKI, the platform, the system for our member, so they can create the role and the management. And we also use the repository, the rsync, so we can push the rower to the repository, and the validator can download this rower, and for the router, they can validate through the port 323. So this is the structure of the RPKI deployment. The first one is the awareness for our members. We need to let them know the importance, the responsibility, the practicality, and the technology. And the second one is identification of the involved members. We will confirm the member with BGP route announcement, and we confirm the contact person who is in charge of the routing route. And also, we have the RPKI customer service. We regularly organize the educational training for the RPKI concept and the ROA setting. We also set up a dedicated contact window for the route setting problem and proactively notify the member with the invalid route. And fourth is the ROA and ROV statistic and analysis. And the last one is the public-private partnership model. So this is our strategy for the RPKI deployment in Taiwan. And this table, you can see the APNIC and the APNIC and our member. They have their job, their responsibility in each system for the CA and the rover and the ROV, the setting and how to use this system. So we also face a lot of the deployment challenge. And the first one is the awareness and adoption, because the many network operator were initially unfamiliar with the RPKI and the rover concept, so which made the adoption slow in the early stage. So we need to tell them how to do and why to do this. And the second one is the technical challenge, because the setup and the maintenance of RPKI CA, RRDP validator, and the RPKI system. We build the whole system and co-work with the APNIC to build the RPKI system. And how to configure the routers for the ROV. And the third one is the compatibility with legacy system. Because some older the network equipment did not support the RPKI, or they need to update to compatible with the RPKI framework. And the last one is the global coordination. Since RPKI is a global initiative, so TWNIC would have had to ensure that the effort area with other RPKI repository and the layer rower are propagated effectively across the global internet routing table. And next, I will share some TWNIC RPKI service monitoring. So we monitor the infrastructure and the OS level, and we also monitor the operational level for the CA RDP, my RPKI portal, and we also monitor the rower and the ROV and the deployment. So because TWNIC build a CA server, RDP server, validator, RPKI, RMS server, so we monitor the OS level, we monitor the bandwidth, the system load, process, the memory, and the disk space for each system. We also monitor the traffic on each system, so we can know the traffic is the very big, the many clients to connect our server. And we also monitor the load average for each system. And we also monitor the RDP server, the global RDP server, and the number of the rower, number of invalid or valid. And we can check the each rower for the this rower's prefix, the AS number, and the maximum length. And this we can also monitor our CA server, and we can know which sub-CA our member, and how much the rower, and how number of the rower, number of the IP address. And this is the RPKI rower validation status of the global and the 5 RIR. So the global valid now is 54%, and there are 3 IR, include the APNIC is over 50%, the valid. And this is the TWNIC global ranking. The rower is derived by the RIPE NCC, and the Taiwan is the number 16. And the rower, the ratio is over 99%. And this one is the global ranking for the APNIC, the monitoring. The status of APNIC, and the Taiwan is 60, and the rower ratio is around 91%. And this is the APNIC for the ROV. The global ranking is 22, and the ratio is around 68%. And this table show the RIPE NCC's
Thank you, Tim. I think we talked about the deployment of ROA in early days, I think, and in TWNIC OPM, I think. And I was very impressed on the monitoring, and he or his team is used such visions to share the status with others. Sometimes it would be the colleagues or sometimes for your members, right?
Yeah.
So this is kind of key things for deploying something in distributed network, such as internet. So we need to move people forward or something. Anyway, can we have some clarifying questions for him, his presentations? We have discussion time at the last, so if you have. Okay. Please go to the mic, please.
Hi, Doug Midori, Kentic. So thanks for the presentation. I don't have a question about the content that you just presented, but I think it was on the 10th of February, there was an incident that expired all of the ROAs for Taiwan for several hours. I don't know if you can share any information on that, or do you know if there'll be any public explanation as far as what took place in that incident?
Sorry, do you mean hot? Sorry.
About 2 weeks ago, all the ROAs that are handled by Taiwan NIC expired globally, and so for a few hours there was no like ROV protection for Taiwan networks. I'm just curious if there was any information about that incident. You may not be familiar with it, but there's some people that are curious to know what took place there. For what it's worth, there was no traffic loss. There was no, routing incidents that I'm aware of. So, the system fails safe, thankfully, but just curious.
Yes, we got this information, the inform, and we found the RV the roller is expired, and we checked the server and we checked the system time. We found there are some the time is not correct, and we adjust the time and we restart the roller and to recover this. Yeah.
Okay, thanks.
Thank you. Thank you. Oh, could you please sit up in front? The next speaker is Dave. from the APNIC RPKI Asia Pacific update.
Good afternoon, everybody. My name is Dave Phelan. I'm from APNIC, and I'm here to tell you what I tell you every 6 months. So I've been a network or was a network and infrastructure engineer for a very long time. I'm now a trainer at APNIC, and I've got a couple of kids, a couple of cats, dog, and I like the occasional meme. So what am I going to talk about? Same thing I talk about every 6 months. Stats, rower coverage, ROV, who's doing what and what isn't working. So rower coverage, here's Jeff's pretty map. Australia used to be a bit greener than this, so we've gone backwards. But globally, as Tim said, we're over 50% around the world. Asia is particularly strong. It's sort of just under the 64% mark, but there's a few more in the plus 50% club now, which is pretty good. I'll just do a whip around the regions. Last time I presented this in New Zealand, I did a bit more of a focus on Oceania, so I'm just going to gloss their numbers and I'll do a bit more of a focus on Southeast Asia and Malaysia, seeing that's where we are. So Oceania is split up into 4 sub-regions. So we've got Australia, Melanesia, Micronesia, and Polynesia. There's lots of different economies in there. So I sort of just round them out as a big lump. But ANZ is up 5% from 6 months ago. So any number you see in brackets, that was when I last presented this. Melanesia is actually stable. There's been no changes in their address space, holdings, or anything else for the last 6 months. So it's same business as usual. A lot of the smaller economies in Micronesia have all been doing some rower signing. I'll talk about a couple of them later. And Polynesia, again, modest increase. Again, lots of small networks, lots of small islands. But yes, winners, Northern Mariana, they went from 62.5 to 100%. That being said, there's only about, I think, a /21 of address space, so it shouldn't have taken long to do. The other big one was FSM, Federated States of Micronesia. They had a very big jump. So that was pretty much everyone has signed apart from one network. If we move into Asia, we split this up into 3 sub-regions. So we've got South Asia, East Asia, and Southeast Asia. Again, all have seen slight increases except for East Asia. Not sure where that has come from, but it's just a minor drop. My guess is it's some new address space that's been allocated that has not been signed yet. So South Asia, very big jump there from Sri Lanka. So they have moved up from, I think last time they were sitting down underneath Nepal. They're now at 98.2%. Bhutan has been sitting at the high 90s for a very long time. If Cloudflare signed the 24 that's announced as a geo of Bhutan, that'll take them to 100%. But generally across the board, South Asia is on top of rower signing. India, not so much. If we look at some of the bigger networks, they haven't signed. A lot of it's down to a lot of disaggregation in their networks, so they're just not doing it. One thing I sort of advocate for is when you're doing rower signing, that's a good time to clean up all of your disaggregated routing, help the routing table a little bit. We move into East Asia. Again, relatively good. So Mongolia is up there. Taiwan is definitely up there. But you'll also notice Taiwan has the highest number of invalids. So when I went digging into these invalids, there's a lot of RTBH /32s. Some of them have been there for a long time, over 18 months. I've also noticed that some of the RENs, they're announcing their supernets. They've signed the supernet, but the individual institutions are announcing their own ASNs with a prefix which is now invalid because there's no undersigning rower. But generally, we're looking pretty solid. Obviously, as others have said, Korea is a problem. We're not entirely sure why South Korea doesn't sign. DPRK used to sign, but they've taken it away. So they've got 124 signed now, or Actually, 224s. They've got a 23 signed. So half their address space is now signed. Southeast Asia, Malaysia. We only need 4 more networks to do their ROAs and they're done. Vietnam is very solid. Again, the invalid rates are not so bad either. If we look towards Laos, they've only sort of in the last 18 months started doing a lot of their signing, and they've made some good gains. So the next part is the big problem, which is the dropping of invalids. There's a lot of red on this map. There are very big chunks of red in this map. Australia benefits from what I call fortuitous validation, but we'll talk about that. So Southeast Asia, route origin validation has dropped a couple of % since I did this in September. South Asia has gone up a bit. East Asia has halved. Someone somewhere has either changed routing and we no longer look like they're actually dropping invalids, but I know for a fact that a lot of these networks are not doing any route origin validation. So fortuitous validation, my upstream validates, therefore I look like I'm validating. That's where a lot of the Australian numbers come from. If you look at the top transit providers in Australia, we're talking about, Vocus and Telstra. They both do route origin validation. A lot of the tier 2 ISPs will buy bandwidth from Vocus. So everything looks a little bit better. Aussie Broadband, one of the larger retailers, are also doing ROV, but they've got a few things that aren't quite right there as well. The other one is there's a lot of default routes. So they may be taking a full table, but they've got a default route sitting on an edge somewhere as a, just in case of emergencies, my traffic will still egress this path. Don't ask me why. Malaysia, the good. As I said, we've got 9 networks that have not signed ROAs, but less than half of those are local networks. Some of them are ID networks that are announced from Malaysia, and a couple of the clouds that don't have ROAs signed for those prefixes. In terms of route origin validation, it's ranked number 2 in Southeast Asia, but number 1 is Myanmar, and you're about half of what Myanmar is. Things to improve, obviously get those last 4 Malaysian networks to sign, and take a leaf out of the Telecom Malaysia playbook and actually start doing some validation yourselves. So what do I need to do? Obviously, ROA, sign your routes. If you still haven't signed your routes, or you have customers that haven't signed your routes, please encourage them to sign, whether it be through your RIR or NIR portal. And the other big one is make sure your ROAs match your actual BGP routing. You've got multiple sources to check how you look from different places in the world. So check your routing against things like Route Views, Radar, Cloudflare Radar, BGP tools, and many, many other sites. Route origin validation. Well, if you're taking a full routing table without a default route, come and attend Smart PKI training, set up a validator and start doing some tests and start dropping invalid routes. If you have a default or a partial feed, encourage your upstream to start dropping invalids. That is all I have. Any questions? Waiting for Jeff to get up.
Jeff Houston, the ROA measurement and masking.
Yep.
We had a lot of trouble setting that up. The ideal would actually be to place a monitoring point, 1 AS beside every AS.
Agreed.
That's kind of impossible.
Yep.
After a lot of trial and error, we came up with using Cloudflare.
Mm-hmm.
And Cloudflare advertise a couple of prefixes. One of them is permanently invalid.
Yep.
The other one permanently valid, but that really doesn't matter. The permanently invalid one is the one we use to basically construct this graph.
Yep.
Our theory is that almost everyone who has a significant number of end users peers with Cloudflare.
Correct. Generally at a IX somewhere.
They just do
Yeah.
that,
Yeah.
even in Australia.
Yep.
And so the amount of transit masking should actually be quite minimal as a result.
PNG is my case in point, right? I can tell who Dataco are using for transit based on their validation states.
Fair point. Cloudflare, I don't think have a presence in
No,
that
they
country.
do not.
So but Cloudflare is one of the better ones in
Yep.
terms of a high density CDN. It's just all of this stuff is a compromise to some extent, but we picked Cloudflare because we don't have to pay them any money. That's really cool.
Yes.
But secondly, they really have a very dense network.
Mm.
And for this kind of work, density is everything.
Yep.
So Cloudflare is the one we're looking at. If you can get to Cloudflare's invalid prefix, something's gone wrong.
Correct.
In your network, most likely. Thanks.
Any other questions? I was very impressed your presentation on the wider area of the coverage calculation comparing with NIRs. And I just thought that you see the difference of the economical areas. And at the same time, maybe this is my guess, you cannot directly talk to operators there, but you are doing the deployment activities and you know the status.
Look, we do a lot of training around RPKI, and it's not just with APNIC, like we partner with TWNIC, we partner with CNNIC to deliver training on these specific topics. I had a discussion with somebody from CNNIC after the APNIC 58 conference because their numbers are embarrassingly low. And they keep saying, okay, well, we need to do more training, we need to do more development, but we've also got a hierarchical problem. So managers don't want things to change because things are working. The engineers may have the will to do it, but unless they get approval, they can't. So there's some different angles we need to attack, and I'm just not sure that it's going to be an easy task in some places.
Thank you. The reason why I'm speaking about this is about the third part of the discussion, the third theme. Why we are doing this, this complex things. Why? If we can measure, it's more beneficial for the users and also us. Okay, thank you so much. Please stay on that. Please keep on the third speaker will be Tom Harrison about ASPAs and IETF updates.
Okay, thank you. Today, I'm going to give an update on RPKI ASPAs and some RPKI-related RFCs that have been published since the last APNIC meeting. So RPKI ASPAs, this stands for Autonomous System Provider Authorization. It's a new object type in RPKI with an associated route classification algorithm. The object allows an ASN holder to declare its set of upstream ASNs or provider ASNs, and a router can then take that data and use it to detect certain types of route leaks, as well as some types of malicious activity. And on the right-hand side of this slide, there's an example of a router detecting a route leak and rejecting the route accordingly. There are two drafts here. They're close to finished. So we're going to implement at APNIC, we're going to implement based on those drafts, but we will wait for them to be published as RFCs before we deploy those updates, because it's always possible for there to be changes before actual publication happens. And we're hoping to get that done by Q4 of this year. These documents have been in progress for quite a while. Fortunately, there are only a handful of issues remaining to be resolved, and most of those are actually more to do with the RPKI router protocol, which is used for communicating ROA and ASPR data to routers, than with the ASPR documents as such. So the first issue is the precise size limit to put on the set of provider ASNs in an ASPR object. The ASPR document currently suggests a limit between 4,000 and 10,000 ASNs. The working group, I think, is generally fine with that. Even at 4,000 ASNs, that's still 10 times the number that would be needed today on the internet. So there's a lot of headroom there. But the RPKI router protocol document still needs to be updated along those lines. The second issue is defining a total ordering of PDUs in RPKI router. The way that RPKI router works is that the server, so usually a validator, sends a set of PDUs, a stream of PDUs to the client, the router. And the intent is that the client would process those PDUs as a unit, so atomically, but whether because of an implementation decision on the part of the client or due to a bug or similar, the client might actually process those incrementally. And if they're not processed as a unit, it's possible to make incorrect route classification decisions. For example, if you have, if there are two rows for two different ASN origins but the same prefix, and decisions are being made on the basis of only one of those rows, then announcements for the other ASN will be rejected incorrectly. I think in general, this is uncontentious, but the exact definition of that ordering is still under discussion. Apart from that, there are a handful of miscellaneous handling issues in RPKI router, mostly to do with error handling, error codes, and stuff like that. But yeah, nothing too complicated there, we don't think. As noted before, none of these relate to the ASPR object or the verification algorithm as such. So hopefully the implementation work we do between now and the time of publication isn't affected by any of these discussions, or at least not affected too significantly. And the issues themselves don't seem too complicated, so hopefully it doesn't take too long for them to be sorted out. Putting ASPRs to one side, there have been a few RFCs published which go to sort of tying off loose ends and just generally refining things a bit with how RPKI works. The first one is RFC 9697, which is about detecting RRDP session desynchronization. So to recap briefly on RRDP, the server publishes what's called a notification file, which acts as an entry point for the protocol. And that file contains a link to a snapshot, which has a full set of the server's RPKI data, as well as a number of deltas, which represent the changes that are happening over time. So when a client is initializing itself, it will fetch the snapshot and use that data to set itself up. And then it will periodically refetch the notification file and see if any deltas have been added and process and download them and use them to update itself. And an important aspect of this protocol is that the snapshots and deltas have their hashes recorded in these XML files, and that allows the client to check that the snapshot or delta that it's fetching actually matches what is intended in the notification file. The base RRDP document is such that the thing that a client needs to remember to make use of RRDP is the last serial number that it fetched. So on the left-hand side, a client that fetches that first file will have a serial number of 1 once it's finished. And then if it fetches that second file, it will see that there's a delta for serial number 2, and it will retrieve that delta. The issue is that there have been problems seen in production where, for example, a publication server realizes it's published some bad data or something like that, and then it restores from backup. And clients will just keep fetching as though nothing's happened, even though the client actually doesn't have the data that they're intended to have by way of the server. And the way that this was detected was by taking a full set of the deltas and hashes that were previously seen and then comparing them on a subsequent fetch. And that's pretty much what this RFC requires a client to do. So instead of just recording the previous max serial, the client has to record all the hashes and serials that it has seen previously. And then when it reconnects, it needs to check that there are no mismatches with what the server is currently saying. And if there are mismatches, then the client needs to reinitialize itself from the snapshot. And this is important because without behavior like this, there's nothing else in RDP that tells a client to reinitialize itself periodically. So a client could operate for quite a long period of time with the wrong set of data if it didn't have behavior like this. The next document, which is along similar lines, is RFC 9674, which is about enforcing a same origin policy in RDP. So if looking at the example in the top left-hand part of the slide, the notification file URL has an origin of rdp.example.net, and the snapshot has the same origin, rdp.example.net, so that's all fine. But in the file below it, the origin of the notification file is still rdp.example.net, but the snapshot origin is now rdp.example.org. So something's gone wrong. The file needs to be rejected, and the client falls back to rsync to keep itself up to date. This is not just about the notification file and the snapshots and deltas. There are also links in RPKI's CA certificates themselves to the RDP server, and those need to match as well. And this document also requires clients to check that the origin of any HTTP redirect that they see in RDP is the same as that they were originally fetching. This is kind of a corner case because it's meant to protect against an RDP server doing something like maybe due to a bug or due to malicious activity, sending a client to some other RDP server to download that data for no real reason. So it's about avoiding unnecessary resource usage on both the client side and the target server side. And the last RFC is 9691, which is a profile for RPKI trust anchor keys. This is about easing the transition from one trust anchor key to another. And at least at APNIC, the main reason for this work is giving us some more flexibility around HSM vendors for trust anchor keys. So if an RIR or another trust anchor operator today wants to change their trust anchor key, then it's a pretty tedious sort of process. The RIR needs to publish a new TAL for the new key. It then needs to publicize that this TAL exists, so NOG lists and working group mailing lists and etc. And then it needs to keep those old and new TALs functional for a fairly long time to make sure that it's not breaking clients unexpectedly. In particular, this hasn't happened before, or at least not for a very long time. So clients aren't prepared for this at all. So there's also that hump to get over as far as familiarity is concerned. What this RFC does is define a new signed object type where the trust anchor operator can sign its successor or replacement public trust anchor key. When a client sees this object, it sets a 30-day timer, and Then when it continues to do its normal synchronization process in RPKI, it checks that that successor key is still being published. And if after 30 days, that key has been published each time, it transitions to using that new key instead of the old key. This is not just about in-band transition, though. Some operating systems publish a set of TALs as a package, and they can use this mechanism themselves to observe TA key changes and then update that package accordingly. So this can be useful even for clients that don't update to using a relying party with this in-band mechanism. This is going to take some time to get into relying party software and etc. But over the longer term, this should make key transition much easier. And that's all. Thank you.
Thank you. Any mainly clarification questions? Yes.
How many RP software vendors are already doing that key change option?
Oh, there are no
None yet?
none yet. No.
Okay. Have they given indication on when?
Not yet.
Okay.
The security mechanism is said like a seat belt, and if seat belt is weak, we cannot protect it by the security mechanisms. Then from the Tom story, the RPKI or ROA SPA is not just giving its functionality, but also the security mechanism itself. By the way, in the ROA deployment seasons, we as registry told the users or the IP address holders accurately, please specify AS numbers for your IP address holding. Then, what about ASPA? What would be the message for the AS number holders? Oh, no, sorry. IP address holders. あれ、私間違えて。No, AS number operators. Sorry.
All good? Sorry.
My question is, what will the message for the AS operators when we deploy SPA?
Oh, very much similar to ROS. We would very much encourage people to create ASPA objects. One thing we learned about ROA provisioning was that without some way of validating that at creation time, people will create anything. And that really subverts the value of the system. So when we do implement this, we will have similar sorts of pre-validation functionality. So people feel comfortable implementing it, or rather creating the objects. But yeah, we would very much encourage this.
Don't we need to create ASPA on a web UI and on my APNIC?
Yep.
So we also we're speaking to people who hold IP address or AS numbers to register the correctness, right? The correct path or correct origin AS, right?
Do you mean as in fetching BGP data to confirm that it's?
I mean that the technical mechanism. I mean that people's actions. I'm sorry, my question is not easy. So for deploying ROA, we as registry told to resource holders to create something correctness, right?
Yep.
For ASPA, we also need to say the people to create the correctness, right?
Oh, very much so. Yeah.
Okay, thank you. The last speaker is Xian Liu. Thank you for submitting your presentation. Please on the stage. It's about his talk about the research titled RPKI Monitor Modeling and Measuring INR Conflicts in RPKI. This is a kind of a hard story for Internet Registry, but it's very important to need to listen to him.
Okay, thank you, Chair. And oh, this is a remote controller. Let me have a try. Sorry. Okay. Okay. Good afternoon, everyone. And this is Liu Xiang from Pengchong Laboratory of China. And it's my pleasure to give this presentation here. And before I start my presentation, I'd like to thank my colleagues and collaborators, which is Li Ming, Zhang Yu, and Ma Di. And this is a collaborative work of us together, and I want to give these credits to them. So today's topic is about RPKI monitor, modeling and measuring INR conflicts in RPKI. This is based on a research project of our team. We developed a system called RPKI monitor, which can detect and measure in a continuous way of the global on the global RPKI data objects to find the conflicts between them. So today's talk will be include 4 parts, and the first one is a brief overview of the INR conflicts, and the second part is about the design methodology of our RPKI monitor, and the third part is about the results analysis, and the last part is about our future plan. So first, I'd like to briefly recap the RPKI system, and I guess that most of you guys of the audience are very familiar with RPKI, so I will just quickly recap this. So the RPKI system basically implements a centralized and hierarchical trust model, and which anchored in the 5 IRs, and So the IR resources are dedicated and allocated in a top-down manner from the IRs to some subordinate authorities and to the end entities. And all the data objects are stored in a distributed manner in some repositories, which are run and operated by some authorities, and some of them are operated in the host model, and some of them are operated in a delegated model. So in this way, we find out that there are some reasons to cause the so-called IR conflicts, and the first one is that the resources, the resource delegation of all the 5 IRs are actually overlapped, which means that the NRO recommended that it should expand the RPKI Trust Anchor certification scope to all IP addresses and AS numbers, which means that, you know, all the 5 IRs, they actually have the, you know, the identical IP addresses and AS numbers that they can manage, they can delegate, and they can allocate. So this is the first reason, and the second reason is that so there may be some misbehaviors and misconfigurations of those authorities which signs the RPKI objects. For example, the fat finger errors and the intentional or unintentional unilateral operations, which will make errors in the RPKI resource delegation. And the third one is AS0. The role with AS0 is a special purpose role, which is used to you know, claim some IP resources to be reserved for the future purpose. But we found out that some authorities will declares some IP addresses with AS number 0, and at the same time, they will allocate or authorize these IP addresses to another AS at the same time. So this will also cause conflicts. And the last one is resource transfer or resource lease, and some similar situations. So even though that the API ecosystem follows the make before break principle, and those kind of conflicts will be regarded as legal temporarily, but we found out that it is absolutely unacceptable that if those conflicts exist for a long time, and in practice they will they indeed exist for even years. So based on that, we propose a ion conflicts model. So generally speaking, we propose that there exist 3 kinds of ion conflicts, and the first one is illegal delegation, including illegal allocation and illegal authorization. So in this kind of conflicts, it means that some authorities allocate or authorize some resources to their subordinates, which does not belong to themselves. And the second one is repetition. So basically it means that some authorities allocate the same resources to subordinates, and they will cause conflicts. And the third one is overlapping. So the overlapping means that the resources allocated to different authorities, they were overlapped. So in this case, conflicts will occur. The second part is about our monitor, our design. So basically, we're not take a very deep dive to the technical details of our detection algorithm. So I just briefly introduce our framework. And so as you can see from this figure, our API framework first, we use different reliant parties to fetch those global RPK repository, and we get the data, and to compare the errors we detect using different reliant parties. We choose 3 different reliant parties, which the APK client, the routing error, and the APK validator. And after we get this, all of this global API data, we can store them into a database, and we create different tables for different kind of data objects. And after that, we can go to the stage 1 of our detecting algorithm. We built the prefix trees of different of all the data, and we also built a certificate path tree for the purpose to help us to enhance the efficiency of our detection algorithm. And in the second stage, we can perform the detection algorithm between different kind of objects. For example, we have detection algorithm between resource certificates and the resource certificates. We have detection algorithm between routes, and we have detection algorithm between routes and the certificates. Okay, so this is the algorithm for the prefix tree construction, and I think we just skip this technical detail. And the stage 2 is the certificate detection. We can detect the conflicts between different data objects. So we also implement our API, ion conflict detection to the API monitor, and we have a real-world system. And so, as you can see from the figure, all the conflicts detected are ordered and recorded in real time, and it is categorized by conflict type, and some details of these conflicts are provided, including the prefix, including the AS numbers and including the conflict duration and the URI of all of these data objects. And we hope that this platform can provide a functionality of the intelligence disclosure. So users of this platform can subscribe their interested the conflict information they're interested, and somehow we can feed the daily digest will then be delivered to the user via email or via some other kinds of methods. And we have to admit that there are some limitations of our work. So as you can see that the conflicts are not necessarily errors, and it is hard to tell A from B. So conflict may be caused by different reasons, but some of them is legal and some of them are illegal. For example, anycast, multi-homing, and temporary conflicts during transfer, this kind of conflicts can be regarded as legal. And some others, for example, caused by misconfigurations, caused by intentional attacks, or caused by unilateral misbehaviors, or some lonely existing conflicts caused by transfer. This kind of conflicts will be regarded as illegal, but it's hard to tell these two kinds of conflicts just based on technical methods. So we have to, obtain some out-of-band information to help us to further, to tell A from B. So including the ISP configurations, including the routing strategy of those operators, and including some commercial information, for example, the customer and provider relationships, the resource allocation strategy, and the resource transfer, and something like that. So the question is, what can the APNIC monitor do? So what we can do is that we provide a continuous and comprehensive detection and monitoring services, and we analyze the IR conflicts. And as I just mentioned, this platform can be regarded as a IR conflict intelligence disclosure platform, and the users can get some information and intelligence that they're interested in. And it also can be a reference value for APNIC troubleshooting. And so what we cannot do is that right now, we cannot accurately determine what exactly a conflict is an error or is not. And we cannot 100% effectively suggest that error recovery. And so users may need to combine their private domain information to further determine whether our suggestion work. So I'd like to say that our APNIC monitor can function like a CT scanner, which can provide some medical imaging information to the doctor, but it's ultimately up to the doctor to make the diagnosis and the treatment plan. We also cooperate with some industries, which is the NNIX in China, which is a first novel IXP approved by the MNIT of China. So we deploy our APNIC monitor in their networks, and we provide continuous monitoring services so that the intelligence and information of IR conflicts will be provided to their network operators and operating systems. And on the other way, we also receive some feedbacks from the operators, and so they can give us their feedbacks with their expert knowledge, and so they can evaluate the real-time performance of our monitor system, and we have a very good cooperation during these months. So regarding the results we have detected, so as you can see the table, so there are very, very numerous IR conflicts that we have been detected. And I have to say that these numbers are collected during the monitoring period in 1 month from 1st November to 13 November 2024. So basically it's 2 to 3 months ago. So as we can see that there are over 90,000 conflicts in total we have detected in 1 month. And so most of them, over 80% of them are type C, which is overlapping conflicts. And the type A conflict shows 0 occurrence, suggesting well controlling of this kind. And the conflicts involving AS number equals to 0 also rarely occurs, but the number is not 0. So less than 1% of the repetition and for the repetition, and about 0.78% for the overlapping. Regarding the regional analysis, as you can see from the heat map, over 90% of the conflicts we detected happens between one single IR, and less than 10% happens of them are inter-IR conflicts. And the APNIC is the most severe region. They count for over 70% of the intra-IR conflicts and almost 40% of the inter-IR conflicts. And APNIC contributes extremely low proportion of the IR conflicts, which is only 0.01% of the total number. So the other perspective we want to analyze is the temporal analysis. Just like I said, most of the conflicts we detected shows the long existing characteristics. So over 90 of them last about 3 weeks in 1 month monitoring. And the conflicts involving resource certificates and those non-zero ASs especially last for a long time. Over 80 of them are fixed during the whole month, are not fixed during the whole month. And the conflicts including AS with 0 numbers show relatively shorter existence, which means that this kind of errors will be figured out in a short time. Okay, so these numbers are about what happens in the 1 month, but since it is about 2 months before now we made this material, and till now I had to admit that most of those conflicts are not addressed yet, according to till now, based on my knowledge, and I don't have the exact number, but I can say it definitely most of them. So in the future, we want to what we want to do with our APNIC monitor is that so it shows that systematic issues beyond simple misconfigurations are ubiquitous in product APNIC systems. So we need to address these things in the future, and we also want to raise the likelihood of a conflict that truly being an error and provide suggested countermeasures accordingly. And we also like to open source our platform and develop unified and standardized APIs for cross-IR communication and cooperation. So in line with that, we also want to develop some automated configuration tools which can fix those conflicts and can be also considered as the next step. Okay. This is my presentation. Thank you for your listening, and feedbacks from industries and the internet community are very important to us. Thank you very much.
Thank you. Questions? Do you have any questions? Mainly clarifications?
Just like to point out the reason your APNIC numbers are so low, they have no inter-RIR transfer policy. So they can't leave APNIC.
Thank you for your points. Thank you. So you mean that resource cannot be transferred inside APNIC. So this kind of errors will be totally avoided. Okay, thank you for information.
Any other questions? Let me have questions. Registries are not only 5 because national level of registries exist. Are those results could be feedback to NIRs? I mean, if we as the NIR found the conflicts, we'd like to fix it.
Okay, sure. If you're interested, we can later we will give you some reports. For example, and you can report to your administration. And exactly, we are doing this right now. So we'd like to provide a deep analysis, a more detailed analysis about the results we have detected. And in the future, we also want to, just like I said, we'd like to open source our platform. So all the users, all the technicals, all the administrators can collect the intelligence, collect the information of the RPK conflicts from our platform. And I hope that will help the RPK community to promote the resilience and the data quality, the trustworthiness of the RPK system. Thank you.
Thank you. And I have a question for Tom about this. If we as the registry found the conflicts between the two registries, so how do we fix them?
By talking to the registries, we're very receptive to feedback along these lines. We're happy to look into any problems that people find. So yeah, each of the RIRs has entry points for this sort of feedback. So best bet is just to talk to the RIRs directly.
Great. Thank you, Xian. Please.
Thank you very much.
Keep on your stage. Thank you. Thank you, everyone. This is the last part, discussions. So I'll go to this place. Can you go back to my slide? And it has discussion part. Thank you. And next slide, please. I try to keep the deep questions later for this part. Is for putting the questions after catching up the core issues. Without core understand, it could be a very technical or very operational or very human error things. If we find the core reason why we are doing this routing security, then it could be many of the questions are not the critical one. Could be, maybe. So I'm trying to catch up with the very core part. I prepared 3 questions for everyone, especially for the people on the stage. And we are looking at the core issues for these sessions. I hope you enjoy this. And if I ask this question for each, the time will be exceeded. So I already put the question for them previously of this session. And will be discussed after their answers. The first the first question is this. Should we approach for 100% raw adoption? How we keep the accuracy? Because there are so many operators, so many IP address holders on the earth. So it could be difficult to be the 100%. But we often say 100%. How do we do that? Can you give your answers one by one? The first speaker, please.
I think 100% adoption is the blue sky, right? It'd be fantastic if we could, but I don't believe it's likely. There's a lot of historic address resources out there that will never be signed. There are resources that are not publicly announced. We'll never see that. In terms of the accuracy side, if you make a mistake or you change your ASN and you don't update your resources, you'll find out pretty quickly that they're not accurate because you'll only get so far on the internet before you actually stop going places. So accuracy can be a self-solving problem, but it's not. There are lots of legacy old rowers out there already where people have created multiple rowers because they can and haven't removed old rowers. You know, they might have said, oh, we're going to move this network to this ASN. They go and create a new rower for that and then don't remove the old one. It just hangs around. Whilst that's permitted in the design of the RPKI system, is it right? It's up to the resource holder to work that out themselves.
Tim, do you have your answers?
I think the ideally is the 100% is ideally the method, but in my opinion, I think if you create a route on the BGP, you should make the role to match this route. Yeah, it's what RPKI do. Yeah, but in fact, there are many challenges, many problems in the global. Yeah, so but I also in my opinion, I think this should be 100% rural adoption. Yeah.
So your strategy is creating visibility and monitoring.
Yeah. Yes.
Thank you.
So I'd like to discuss about how to keep the raw accurate, or how to enhance the accuracy of the RPK data objects. As I just discussed in the last session, I guess in some of the experts on this room, I found that it's my personal opinion. I think that's transparency and auditability is the key to enhance the RPK accuracy, because so in these days it seems like that we know that there are some misbehaviors of those authorities. There are some misconfiguration or some errors of those authorities, but we have no way. There's no means. We can punish them. We can replace them. So they have. Seems like they have to pay nothing for their errors. So is there anything that we can do to change this scenario and to make all the behaviors of those authorities, transparent, publicly auditable, and if they make errors, they will pay for them.
Just one note on that. Your B type, which is multiple rowers, is not necessarily an error,
I see, I see.
right?
No, so conflicts may not necessarily be error, but somehow maybe just let us assume that somehow a true error has been detected. So, and we can determine, we can be sure that someone should be responsible for that in RPK. So how can we make them pay for that? I'm not very sure.
Oh, Madi.
Hi, Najib. May I say a few words on this topic? Some of the people on the stage say the 100% is ideal, is a good thing, but from a perspective of internet user, I don't think we have to pursue for 100% of ROA adoption. Okay, and I would settle for that, a critical mass of the IP address prefix, such as the top service provider and role server IP address and the IP address of LAMP server of top level domain could be verified by ROA. That's okay. And if they are doing so, they are actually setting a very good example for the RPK adoption. So, yeah.
Jeff.
Hi.
Hi.
Jeff Houston here. Look, you should be really, really careful what you're asking for, because the risk is you might get it. And if you get it, you don't want it. Why? Security credentials don't tell you what's bad. You can't find that out. There's no bad or evil bit. All you can do is sign what's authentic. That's all. So how do you identify what's bad? If you know what's good, that doesn't help you with what's bad. It's just good. So at the moment, with partial adoption of ROAs and partial use of this, what we actually have is 3 categories. 1, it's good because everything authenticates. 2, we have no idea. And 3, there's some stuff that contradicts what's good, and we call that invalid. But what if you signed everything? What if you assuredly signed everything? If you find something that matches, that's good. Everything else is bad. Drop it. Now, at the moment, we have a system that is fault tolerant. You can drop a bunch of ROAs, as people do. TWNIC did a few days ago. And what's the consequence of going from authenticated to unknown? 0. There is no consequence. Nothing happens. It's fault tolerant because a system that kind of assumes 3 states means that if it's not good, it drops into unknown, not fail. If you get what you're asking for here, you're producing a system that is intolerant of any form of failure. It immediately drops from yeah to no, I can't see you on the net. Good luck with that. Now, we're not very good at this stuff. We do errors every day. It just is the way we operate this thing. We actually rely on tolerant systems. We rely on the fact that if it's not provably good, it can slide into unknown, and that's okay. But if you don't have that ability, it's good or it's evil, and I'm going to throw it out, then all of a sudden, everything you do on that keyboard matters like crazy. And you will get outages on a minute-by-minute level because previous experience over the last 50 years says we're pretty crap at this job. If you really want 100% ROA adoption and an intolerant form of validation, you can get it. It's easy to build, but you don't want to live in that world because the network won't work very well. So like I said, be very careful about what you ask for, because the real problem is that if we deliver it like that, you won't want the answer. You really don't. Thanks.
Thank you. Ordinarily, I'd like to discuss with this kind of things. I thought that ROA and SPA is like a self-displaying object. What is the correctness? We, as the people using IP address, need to say correct things. But it's like a car accident or material stolen in the house. We don't need to 100% locked or 100% of seat belts. If consequently, if we, as the user of internet, are helped, we can say it is adequate. But it's difficult to say what percentage is adequate for partial deployment of this system. Let me go to the second question for last 5 minutes. ちょっとこれ戻る。よいしょ。次。How can we motivate operators to deploy raw ROV more effectively, or how can we lower the technical barriers to deployment? This is a very typical one, so please let me go to the next one. Okay, this is a very important and very ambiguous question for you and the people on the stage. What does it mean to strengthen the internet itself against misoriginated routes? The simply answered, well answered is deploying ROV or our way, but it requires people's creation of the correctness, right? But we cannot make them 100%. But I think some of the people did the deployment activities said that it comes out as the correctness of the contact or the chances to talk with our customers. Those are not the purpose, but consequently making the situation better as the misoriginated routes. What do you think of this question, or what's the answers for you?
Five characters, BCP38. Let's just start there and get everybody doing the right thing. So make sure you are actually doing filtering outbound, problem number one. Don't allow your customers to send things to you that they shouldn't, number two. Number three, stop people interacting with the CLIs of routers. The number of times the fat finger mistakes have caused problems are ridiculous.
Automation.
Who was it? I'm sure Doug will correct me if I'm wrong, but wasn't it Ross Telecom missed off a 1 or something on a prefix about 6 or 7 months ago? Everyone went, oh, Ross Telecom are hijacking. No, they were missing a number. Get rid of the human element. Automate all the things. Stop sitting at a CLI. You've got better things to do.
Tim? No. Oh, no.
Just me? All right.
Okay. Can I ask the floors for saying at the last part? Oh, of course. Yes. Madi.
I think, as we all know, the internet is functioned from several different distinguished layers. So when it comes to security, we should be aware that we can make use of the up layer protection. For example, if a DNS server is being hijacked by the attacker, but if this server is protected by DNSSEC, this issue could be remedied. This is a good example.
Jeff Houston again, I don't know why I keep coming to the mic, but you keep on asking these questions and you need to be reminded of a lot of history. This topic is about as old as routing. And the original approach was actually really quite sane. What you needed was a second commentary on routing. Say what you intend to do and do what you said you intended to do. So how do you say what you intend to do in routing? The answer was the routing registry. So the idea was that you described, ASCII text, whatever, the routes that you intended to advertise to the net. And then you went and did it. And anyone else could use the routing registry to generate a filter to say, you did more than you said. Naughty you, I won't believe this excess nonsense because you actually didn't mean it. Because you said what you were going to do. You didn't need any crypto, you didn't need anything, you just needed a routing registry. The problem is that a routing registry implies one element, a unique sort of entity that runs the routing registry. And, you know, Dijkstra's principle applies. As soon as you get two, any number is as good as any other. And we ended up with about 25 different routing registries, all of which had out-of-date, inconsistent information. The model was good. The implementation was fatally flawed. You now look at trying to apply the magic of cryptography to this problem. It's routing registries on steroids. Is it any better? No, it's exactly the same thing. Say what you're going to do and do it. It's as strong as it was in 1990, no stronger. It's as weak as it was in 1990, no weaker. It's the same principle. After 30 years, when you can't train operators to say what you're going to do and then do it, maybe there's a different lesson to learn. It's not the tool that's the issue, it's the discipline of behavior of being part of the routing system that's the issue. It's a people problem. It's not a technology problem. And all the crypto in the world is going to help you not at all if that's your problem. Thanks.
One comment on yours, Jeff. Have we not, with RPKI now just gotten us back to 5 routing registries, give or take?
Yes, it was an overkill solution to give you back uniqueness.
Correct.
Because there's basically one PKI. Oh my God, how much does it cost to learn a simple lesson? And the answer is all of this crypto, all of this overhead to learn a really simple lesson. One registry is what you need, not 25 or 100.
Which we still can't do right. The amount of bad routing practices, bad filtering that is still going on,
right? But
for generations, right?
You get the point, right?
I know. Yeah.
That the RPKI itself isn't really the intended sort of exercise that's going on here. You need to set up the routing system and a different form of base truth and be able to match the two. And if you conform to what you said you were going to do, the rest of us will go, fine, sounds good to me, because it's your routes, right?
Okay, it's time. Please give large applause for the presenters, very refined presenters. Thank you for giving a presentation. And this is my very first time chairing routing security sessions and I will continuously try to looking at figuring out what is routing security, and the attendees can have very refined presentations. Stay tuned. Please come to the next routing security sessions. Thank you.
Longing for someone to hold me, it could be anybody, but you chose